All right, let's talk speed. I mean, real speed. In the world of programming, it's a high stakes race where every single millisecond counts. So, which language truly delivers the ultimate performance? Well, we're about to find out. And really, that's the big question, isn't it? I mean, think about it. From the stock market trading bots making decisions in a flash, to the amazing graphics in the video games you play, raw performance is absolutely critical. So, who actually sits on the throne of speed? To get to the bottom of this, we're going to count down the top 8 fastest programming languages according to our source material. We're starting at number 8 and making our way all the way to number 1, the undisputed champion. So let's dive right in. Okay, let's kick things off. First up, we've got the languages that are, don't get me wrong, incredibly fast, but they just miss out on those very, very top spots. Let's see who's in this first half of our list. And kicking off our countdown, coming in at number 8, is a language that's an absolute powerhouse in its own little world. And that language is C Sharp. You've definitely run into it, probably without even knowing. Ever used a Windows PC? Or played a game made with that famous Unity engine? Yep, that's C Sharp working behind the scenes. Yeah, those are its two big claims to fame, building solid, robust applications for Windows and being the go-to language for pretty much all game development in Unity. It powers tons of indie hits you've probably played. So yeah, it's fast and it's a real giant in its field. All right, let's move on to number 7. Now this one, okay, it might not be the absolute fastest on our list, but you could easily argue it's one of the most influential languages in the entire world. We're talking about JavaScript, the language that basically runs the entire internet as we know it. What's just crazy about JavaScript is how it's everywhere. Our source points out that it's probably the most popular programming language on the planet. And you know what? Thanks to some seriously powerful modern engines, it's gotten surprisingly fast, which is why it's earned a solid spot right here on this list. Okay, coming in hot at number 6, this is a language you probably use every single day, especially if you're a fan of a certain tech company named after a piece of fruit. Yup, it's Swift. This is Apple's own modern programming language, and they designed it from the ground up with two things in mind: performance and safety. You know that super snappy, responsive feeling you get when you use an iPhone? A huge part of that is thanks to Swift. It was literally built from scratch to be as fast as possible on Apple's hardware. Whoa, okay, I gotta pause here for a second. The way our source talks about this next one, they use some pretty dramatic phrasing. So get ready for a surprise. And here it is, the language that has shocked a ton of people by just how fast it's become. It's Python. No, seriously, the language that everyone loves to criticize for being slow has somehow cracked the top 5. So, how in the world did that happen? Well, it's all about evolution. The Python community has been doing some incredible work lately, and thanks to a bunch of new optimizations, it's just so much faster than it used to be. It absolutely earned this spot. All right, rounding out this first chunk of the list, right before we get into the heavy hitters, we have a true industry veteran. Coming in at number 4 is Java. For decades, this language has been an absolute cornerstone of big, enterprise-level software. Java has always had a reputation for being fast, for sure, but its real superpower? Portability? You know that whole write once, run anywhere idea? That's Java. It means you can tap into its performance on almost any system imaginable, from huge banking mainframes all the way down to the Android phone that's probably in your pocket right now. Okay, deep breath. We've made it to the podium, the top 3. These next languages are just modern marvels of engineering, built for one thing: insane performance. Grabbing the bronze medal at number 3 is a language that comes from one of the biggest names in tech. It's Go, or as you might hear it called, Golang. And it was cooked up inside Google to help them solve their own, massive planet-scale problems. And Go has a secret weapon, and it's called concurrency. Now, what does that mean? It's basically the ability for a program to juggle a whole bunch of tasks at the exact same time. Go makes this super easy, which is perfect for all the modern processors in our computers that have multiple cores. And now for our runner-up. The silver medal goes to a language that's really interesting because it was built with two very clear goals that almost sound like they shouldn't work together. At number 2, we have Rust. This language has developed this, almost fanatical following, and for good reason. Its approach is totally unique. So here are Rust's 2 big goals. Goal number 1, guarantee memory safety. This is huge because it prevents a whole category of really nasty common bugs. But here's the kicker. Goal number 2, do all that without sacrificing a single ounce of raw bare metal speed. It really tries to give you the best of both worlds, safety and speed. And that brings us to the top, the number 1 spot. But what's really interesting here is that our source doesn't just pick one winner. Instead, it's kind of like a tie, representing 2 different but related levels of programming. So at number 1, we have the undisputed foundational champions of speed in the entire world of computing. Okay, so here's how this breaks down. On one level, you've got the absolute titans, C and C++. For decades, if you needed raw power and direct control over the computer's memory, these were your tools, period. But if you go just one level deeper, you get to assembly. This is as close as a human being can get to speaking the computer's native language. It is, quite literally, as fast as you can possibly go. There's nothing faster. So there you have it. That's our countdown. From C# all the way down to pure assembly, it's pretty clear there are a lot of different ways to get performance. But this whole thing brings up a really big question about where we're headed. Think about it. As computers themselves just keep getting faster and faster, are we still going to need these hyper-optimized languages like C++, Rust, or even assembly? Or will our own ambitions for what software can do, bigger games, smarter AI, more complex simulations, always push us to squeeze out every last drop of performance? That's the big question we'll leave you with to think about.